All right, welcome back. Hopefully you were able to find the formula for correlation on your formula sheet. So this is how it's actually found. So suppose we have data on variables x and y. So the values for the first individual are x1 and y1, so that would be your x-coordinate and your y-coordinate. The values for the second individual are x2 and y2, so on. So this is what's going on. So if you look at this formula, inside here, you have the x-coordinate minus the mean for the x-coordinate divided by the standard deviation of the x-coordinate. So for instance, if we were doing this on our previous data where we were talking about the relationship between 40-yard dash time and running long jump distance, this would be for the 40-yard dash time. So your 40-yard dash time minus the mean 40-yard dash time divided by the standard deviation of the 40-yard dash time times your running long jump distance minus the mean running long jump distance divided by the standard deviation of the long jump distance. Now, you've seen this kind of thing before. A number minus a mean divided by a standard deviation. That's how you find a z-score. So what you're basically doing is you're taking the z-score in the x variable times the z-score for the y variable plus, for the next dot, your z-score for the x times your z-score for the y plus, and you add all these up. And it's kind of an average because you see this 1 over n minus 1. Now the version that's actually on your formula sheet looks like this. So r is 1 over n minus 1 times the sum, remember uppercase s in Greek, the sum of all your z-score in the x direction, z-score in the y direction. So you find both of these for each number and you add them all up. So for the example that we just did, we would have 13 products. So you find a product for the first term, a product for the second term, a product for the third term, all the way up until your 13th term. You'd add all these up and then divide by n minus 1. In other textbooks, I've seen it written like this, where you have z-score for the x times z-score for the y. Now, your book in the homework asks you to do this by hand. I think this is pointless. Even when I was in school, this is not something that you did by hand. It's a really good thing to know how to do. But again, this is not something that you really necessarily want to do by hand. So what I'm going to show you right now is how to have your calculator calculate correlation for you. Please, 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 please pay attention. This is really, really important because it's not the same way that you did it in algebra. So first things first, on your calculator, go ahead and under your stat, go ahead and put in the data for those two lists, so your 40-yard dash times and your running long jump distances. Pause if you need to, and I'll be here when you get back. I've put in the data for these. I'm going to go ahead and just make a scatter plot just to make sure it looks pretty good. It should look like the one I got by hand. So remember, your stat plots are under your y equals, so I go second y equals. And the first type here, that's going to be a scatter plot. And I put my x and y in L1 and L2. I'm going to make sure I do a zoom stat. Remember, that's 9th one down. So zoom and then hit 9, which is typically the one that you're going to be doing. So I'm going to do a zoom stat, and it's going to do it for me. And I use the little square boxy things, so that's what that looks like, which is great. Now to find correlation, this is what you do. I'm going to quit and go back to my home screen. I'm going to do stat, calc, and it is not the 4th one down. So some of you guys have probably already done it. It's actually not on this first screen, which is kind of annoying. It is actually, at least on my operating system that I have here, the 8th one down. It's linreg a plus bx. And we can talk about the reasons for that in class later on. But for now, take my word for it. This is the way we do it. We're going to do a linear regression, and we're going to get an answer in the form a plus bx. So I do that. It's going to ask me what's your x and what's your y. Now, if you are doing this on an 83, you're going to do your x list, comma, your y list, comma, and then where you want to store the regression equation. If you are using a new operating system, you are seeing something that looks like this. So let me show it to you this way first, and then TI-83 folks, I'm going to come back and do it the other way. So I had my x and y in L1 and L2, so that's fine. We don't really ever use a frequency list. This one asks you, where would you like to store your regression equation? Now, I want to store it in my y1. What that's going to do is it's going to take my line of best fit equation and put it in there. This is not something you really need to know how to do today or for your homework, but just to show you how to do it, since we're here anyway. It's under F4, which you can see is this trace button here. So I'm going to go alpha to get the green buttons and F4, and I'm going to choose Y1. So this means it's going to calculate line of best fit from L1 and L2 and store the answer in Y1. Now, a couple things here. First of all, you probably got y equals a plus bx, and we'll talk next class about why that's incorrect. And you had a value for a and a value for b. Again, that's not really important right now. You may not actually have gotten these two numbers here. There's something called r squared and there's something called r. Now, we are interested in this number here. That's my correlation. So the negative 0.747, whatever. That is what I'm interested in. If you did not get that, then you are going to need to change your mode. And I'm going to show you that right now. So next to the second key is a mode button. And this shows you what your mode your calculator is in. So on the top here, this is normal, float. The ones that you may have changed for other math classes are radians versus degrees, depending on what other math classes you're taking. This is going to mean when you're dealing with trigonometric functions, your answer is going to be in radians or degrees. The next one is about function mode versus parametric mode. Probably not too many of you guys are doing stuff in polars right now. Some of you guys might be. The other one that's going to be probably you might have changed is going to be whether your answers are real numbers or if you're using complex numbers down here. Again, most of you guys probably are not using de Moivre or anything like that for polars yet, although some of you might be. But what I actually need for stat is going to be on the next page. I'm showing you this because in case you do need to reset your calculator, don't forget to put your things back the way they were. MathPrint is what I want to leave on. This tells you about whether your answers are automatically in fractions or decimals and things like that. The ones that matter for us right now are the two bottom ones. Stat diagnostics you want to be on. So if it's not on, go ahead and turn it on now. Stat wizards is what makes it prompt you. So when it says L1, L2, and all that stuff. So I'm going to turn it off just so you can see what it looks like when it's off. Again, the default for 84 and higher is going to be on. So now, if I go stat calc and I do a linreg a plus bx like this is what it looks like on the TI-83. So I could do L1, comma, L2, comma, and then for the Y1, that's going to be under variables. It's a y variable, and it's a function because it's one of the things that you do when you're trying to graph functions. And then you can run that, and it's going to look like it looks like on the 84s. So again, just don't forget to turn stat diagnostics on. Stat wizards, if you have it, should also be on. Now, the other thing it's done is it's taken that equation and put it in your y equal, so it copied and pasted it there. So if you do look at your graph, it should draw you a line going through your data. And that's always a good thing to do. But for the purposes of today, the only things that are really important is that you know how to do this in order to calculate your correlation. And it's going to be this bottom number here, r equals negative 0.747, etc. There's a whole bunch of numbers there. So this is how you find correlation. Again, don't forget to turn your mode, change your modes to have stat diagnostics on if it's not on. I also did a handout with Chapter 3 calculator instructions that's going to be on Blackboard in case you have a hard time following this and you want to do it step by step. You push this button, that's going to be on Blackboard. So let's finish up with a few more things. This is a picture I stole from Wikipedia, and I think it's a really good one to summarize some of the points here. So if you look at this top row here, if you are close to 0, you have weak or no relationship, but the closer you get to either positive or negative 1, you get closer and closer to a perfect linear relationship. Also, these numbers do not tell you anything about the slope. These down here give you examples of perfect positive correlations. And you notice that these numbers do not tell you anything about the slope. It just tells you the direction of the slope. It doesn't tell you what the slope actually is. Same thing for negative. Of course, this one right here is going to have a correlation of 0 because even though your x is changing, your y is not changing at all, which pretty much means there is no relationship between these two things. Because if one changes and the other one doesn't budge, doesn't appear that these things are related. Correlation is going to be 0. And the last row on here shows you that pretty clearly there is a pattern. There seems to be some kind of relationship between your x and your y, but these are all examples that have a correlation of 0. And that is because, once again, the correlation is a number that tells you the direction, positive or negative, and strength, close to -1 or +1, of a linear relationship. If it is not a linear relationship, it doesn't tell you anything. Because again, here, these clearly have relationships, but they are not linear. So again, because correlation is so commonly misunderstood and misused, and because it is commonly asked about in the AP exam, it would behoove you to go and make sure you got those properties correct. So additional facts is just the stuff that I just told you. The correlation does not tell you about the slope, only the direction of the slope. Correlation is 0 for horizontal and vertical lines, and it only tells you the strength of linear relationships. Last thing, if you are told interpret the correlation, that means exactly the same thing as interpret a scatter plot. This is important. Some of you guys are going to get this wrong on the quizzes and tests for this unit, even though I'm telling you now. If it says interpret the correlation, it means make a scatter plot, first of all. Make a scatter plot, then describe direction, form, and strength, as well as any outliers. I am not kidding. So if it says interpret the correlation, make a scatter plot, describe direction, form, and strength, and outliers in context. You have been warned. And of course, lastly, does a strong association between two variables indicate a cause and relationship? And I think you guys know by now, of course not. It just means there's an association. It does not necessarily mean that changes in one cause changes in the other. Just that changes in one are associated with changes in the other. So that's it for now. That should be enough to get you through your homework. Please come ready with questions for next class. And yeah, get your great guided reading notes done if you can. Again, I know that not all of you have printers, so if you want to do it on your own paper, that's okay. But you should have received your guided reading notes handout already. So for most of you guys, I don't think that will be much of an issue. So again, come ready with questions, and I will see you in class.